Hello everyone. Today we are looking at a project called Mellum, which is an open weight model family specifically designed for an in-IDE code completion. While the industry often pushes for bigger is better, this paper argues that for real-time coding, a compact 4 billion parameter model is actually the optimal choice. It's a Llama-style architecture trained on 4 trillion tokens of permissively licensed code. The goal here wasn't just to build a model, but to create a reproducible industrial blueprint for AI tools that work at scale. The paper starts by identifying why off-the-shelf models usually fail in a professional setting. First, there's licensing. Many popular models have restrictive terms that prevent companies from self-hosting or redistributing them. Second is performance and user experience. Chat-oriented models aren't great at filling in the middle. They tend to ignore the code that already exists below the cursor. Finally, there's data governance. Without transparency in training data, enterprises face a massive risk of concept drift or compliance violations. Mellum was built from the ground up to solve these three specific issues. A key theme in this lecture is engineering by constraint. In a production environment, an AI suggestion is only useful if it's near instant. The target here is a latency of under 500 milliseconds for 90% of requests. From a hardware standpoint, the model is sized to fit within 80 GB VRAM GPUs like the H100. This allows the system to handle hundreds of thousands of users without requiring an impossible amount of infrastructure. The model's development follows a rigorous three-stage pipeline. It starts with pre-training, where the model learns the foundational syntax of dozens of programming languages. Next is supervised fine-tuning. This is the specialization phase where the model learns till in the middle and multi-file context. Finally, we have DPO, direct preference optimization. This uses an LLM as a judge process to fine-tune the model's style, ensuring it produces clean code that stops exactly where it should, rather than hallucinating extra lines. One of the standout technical innovations is scope-preserving FIM. Standard models are often trained by cutting code at random points, which leads to zaring, broken suggestions. Mellum uses a code engine to identify syntactic boundaries like the start of a function or a block limit. By training on these logical semantic chunks and limiting them to 700 characters, the model learns to respect the logical structure of the code. This results in completions that feel far more natural to a developer. To provide multi-file awareness without massive latency, the system uses a high-speed RAG pipeline. It starts with path distance discovery, which finds related files based on the project hierarchy and the user's recently opened tabs. Instead of expensive semantic embeddings, the system uses intersection over union to score code chunks. It's a computationally efficient way to find the most relevant pieces of the project and pack them into 88,000 context window, giving the model a global view of the code base. Even after fine-tuning, models can be over-talkative, generating code that developers didn't ask for. The paper addresses these using DPO to reward precision. By using tree-sitter parsers to label the data, the model is trained to recognize semantic boundaries. This forces a hard stop at the end of a logical block. The result is a shift from verbose, functionally unhelpful generations to compact, readable code that ends exactly where it's needed. The chart illustrates the power of stopping. You can see that generic models often blow past block boundaries, predicting an average of 16 lines when only a few are required. Mellum, especially after DPO, averages around 3.8 lines, which is remarkably close to the ground truth. This is a critical metric for IDEs because it prevents the AI from becoming a distraction. To evaluate performance, the paper introduces the JetComplete benchmark. They move away from the rigid exact match metric and uses a custom KK score, which is based on normalized Levenshtein distance. This metric mimics how a human reads code from top to bottom, counting matching lines until the first error. In this stage, the 4 billion Mellum model achieved a score of 0.69, outperforming much larger 7 billion models like CodeLlama and DeepSeek Coder. Finally, we have the production telemetry from hundreds of thousands of users. They track the ratio of completed code, ROCC, the actual percentage of characters in the editor written by the AI. For Python, the ROCC jumped from 25% with local models to 39% with Mellum. The acceptance rate, how often a user actually hits tab, rose to 34%. All of this happens with an average processing time of 400 milliseconds. So, proving the model is both high quality and production efficient. In conclusion, and the primary lesson from the Mellum project is that task focus beats raw scale. By tailoring a 4 billion model for specific IDE constraints like semantic splitting and high-speed RAG, we can achieve results that systematically outperform generic giants. The paper offers a clear, reproducible blueprint for the industry. By releasing it under Apache 2.0 license, it makes these high performance, private, and efficient tools accessible to the wider community. Thank you for joining.